For this first section, we're going to talk about variation functions, kind of go over the different types and how to solve them. So there are three main types that we're going to focus on in this section. They are the direct variation, the inverse variation, and then the joint variation. All of these variation problems are going to have this constant, which they use the letter K to represent that. The constant would be the piece that remains unchanged. So it's known as the constant of proportionality. So it basically keeps the problem to be the same regardless of what other numbers maybe get thrown in when you're then evaluating it to solve for a new value. The first one, and probably the most used, is the direct variation. And so that equation looks like y equals x, would be like a general example. So y varies directly as x. So if I actually looked at the graph of this, this is what that line would look like if I just do a rough sketch. So whatever my y value is, my x value is going to be. They're going to match exactly the same on all points of the line. That's basically the idea behind the direct variation. Now, most of these problems, we're not going to be looking at the graph. We're just going to be given information about the problem, and we're going to use this equation to help us solve them. For example, this first one says, if y varies directly as x and y equals 12 when x equals negative 3, find y when x equals 6. This is really kind of broken into two pieces here. The first half of this talks about how to create your direct variation equation, while the second half is wanting you to use your equation that you found to then evaluate it for a new variable or for a new value. So y varies directly as x. That tells us that we're going to use that equation like that y equals x, except we have to now include that constant. So y equals kx. This one is saying that y is 12 when x is negative 3. So k times negative 3. So what I'm trying to do here is solve for k so that I can write a new equation that would relate to all of these examples. Like if I wanted to find any point on this line that I was graphing out there. So I'm going to end up dividing by negative 3 to get my k alone. And I get negative 4 for that. So to write my equation now, instead of saying y equals kx, I'm going to say y equals negative 4x. So if I were to graph this, it would look a little bit different than that equation that I graphed up above, because it's no longer going through the origin, because my slope has changed. Like that negative 4 is in the slope there. If you think about y equals mx plus b, negative 4 is in the slope spot, so that's going to cause this line to look a bit different. So if I wanted to evaluate for any point on this line, if I knew one of the coordinates, if I knew the x or the y coordinate, I could use this equation. So now we're going to use that second half of the problem that says find y when x equals 6. So I'm going to take negative 4 times 6, which is going to be negative 24. And that's my answer. Okay, so why don't you guys give this one a try. Go ahead and pause the video, and then when you're ready for me to kind of walk it through with you, go ahead and hit play. So we're going to use that same form, y equals kx here. For this one, they give us the information that y is 10 when x is negative 3. So 10 equals k times negative 3. Now for this one, when I divide by negative 3, I'm going to have a fraction for my k, which is all right. It's just going to be that negative 10/3. So then if I go to write my equation now, it's going to say y equals negative 10/3 x. So the second half of the problem says find y when x equals 15. So we're going to take negative 10/3 times 15, and we end up with negative 50. All right, moving on to the next type of variation. This one is called the inverse variation. So the x and the y are doing opposite things. So like as one value goes up, the other value is going to go down, or vice versa. So this equation looks a little bit different. It says y equals k over x instead of k times x like we saw with the direct. An example of a graph like this, we dealt a lot with inverse variations last chapter when we were graphing those functions and then finding the inverse of the function. This is what this would be relaying to, like those types of problems. So one example would be if you have one graph, one function looking like that, the inverse would be on the other, kind of diagonal from it, because you're using that y equals x line to reflect over. So let's do a problem here where we solve. Now we're going to have a little bit different of an equation. It's going to be that y equals k over x. So this one says that if y varies inversely, so we're going to use that y equals k over x. And again, it's broken into two parts. The first half of this problem is the information used to help you solve it, while the second half is information for you to use to evaluate at a different point. So we're going to have y equals 16, k is my constant, x is going to be 4. So to solve for k, I need to get rid of that 4, which is in the denominator. So I'm going to multiply by 4 on both sides to get that to cancel. And so I get k equals 64. So to write my new equation, it's going to say y equals 64 over x. And to evaluate this one, I'm going to take 64 and divide it by negative 10. And so this is going to be negative 6.4. The last type of variation is the joint variation. So this is when y is varying jointly with two or more variables. Most commonly, you're going to see something that looks like this, y equals kxz. So the x and the z are being multiplied together. They're adding in another variable to this problem, and that's where that jointly comes in. So for this one, it says if y varies jointly as x and z, so y equals k, still my constant, times x times z. It says that y is 40 when x equals 2 and z equals 4. If I simplify, I have 40 equals 2 times 4 would be 8k. Divide by 8, I'm going to get k equals 5. Okay, so now using that to write my new equation, y equals 5xz, I can now evaluate y when x is equal to 3 and z is equal to 5. And this is going to give me 75.